Okay, so everybody, I'm going to show you how to solve this question that's been bothering us for a long time, right? So let me read the question first. A decaying radioactive ore originally weighs 27 grams and is reduced to 18 grams in 1,000 years. So we're going to use, I'm actually going to use the solution key so you can compare the answers really quickly. So here in the question, it says use exponential regression on your calculator. So actually there is a function in your calculator that's going to give you this b value, so we can write the function, the exponential decay function. But before we actually do that, I'm going to show you how that we can find the b value with some manipulation of the numbers. So the first thing we want to do is gather all the information. So a decaying radioactive originally, there's a big hint there, originally weighs 27 grams, right? So our initial value, you remember the equation, y is equal to a times b to the x power. That is a general form of an exponential function, right? And a was actually initial value, and b is our growth factor or decay factor. In this case, it's being reduced, so it should be decay factor. And B is actually stands for time. Okay. Now, so our initial value A value is 27. Okay. We don't know our B value, but we do know how long it took for it to become 18 grams. So we know that X is actually 1,000, and that gives us 18 grams. Okay, now using this equation, we can find the b value. So the first step would be to divide both sides by 27, right? And the 27 to cancel. Now b to the 1,000 power, to cancel, to get rid of this 1,000 power, we want to take the square root, not square root, 1,000th root on both sides. So we want to do this, 1,000th root on both sides. Okay, now on the right side we have b all by itself. On the left side we have 1,000th root of 18 over 27. Okay, I'm using my mouse to draw these, to write these things, so it's not completely neat. So now we can use our calculator to find the value of b. Okay, so I'm gonna turn it on. So how do you do 1,000th root in the TI83 or 84? It's actually TI83 plus. So you see the yellow square root sign there? So if you do second and x squared, it's going to, second x squared, it's going to give you the square root. But if you go to math and number 4, that's a cube root. And number 5, that's the x number of roots. Okay? So we can use number 5 here, but before we type in number 5, I want to type in 1,000 first, and then do number 5. So this actually means 1,000th root of the number in the radical sign, which is 18 over 27. Okay, now that 0.999594617, it probably will go forever since this is a irrational number, but that is our b. Cool, isn't it? So we can rewrite the equation using that b value, 0.99959. So this guy cut it in 5 decimal points. So let's use the same number. So y is equal to our initial value 27 times our b value 0.99959 to the x power. That will be our exponential decay function. Now we can plug in any number to get the y value, or have the y value and find how long it took to get there. Okay, now I'm going to show you how to find this equation or this function using the exponential regression function in your calculator. So now first go to stat. Let's go to stat and number 1, edit. Click on edit. It's going to give you a table, and this is where you can put your data, a set of data, and then it will automatically create this function, exponential function for you. So our data, we have 2 points here with the given information. So originally weighs 27 grams, means when time is 0, the mass of this ore is 27. Okay, after 1,000 years, when time 1,000 years passed, the mass became 18 grams. Okay, so how do you choose x value and y value? Why not? Why can't we choose let this be x and let that be a y? Because when you graph it, x value always increases that way, right? So whatever always goes positive the same way, and it's increasing on a regular basis. So every single grid unit will be 1 year here. So that's a good x. The time is always a good x. So whenever you see time, 90% of the time will be your x-axis, or x value. Okay, so we're gonna put it. We're gonna plug in 0 into x1, and then 1,000 into x2. We're gonna go here. We're gonna plug in 27 into y1, 18 into y2. Now we're gonna go to second y equals. So that's stat plot, right? Usually the plot one, the plots are always off, but you want to click on for plot one. Okay, and plot one comes from the stat we just edited. Okay, now we can graph it, or what we want to do is actually go to second trace, which is calc. Oh, sorry, not that calc. Go to stat. Go to this calc. So scat calc. So if you go to second column, go all the way down, go to 0 where it says exponential regression. So click on that, and we're gonna find the exponential regression of, go to vars, and go to y bars, and go click on function number 1 and y1. So we're gonna find the exponential regression of y1 function we plugged in with this data plot right there, and click on that. It's going to give us all the necessary values that we need to find this equation right there. Okay, so same thing, a value is 27, b value is 0.99959, and then x is just a variable.